Welcome, ladies and gentlemen. We want to talk about the so-called shuttle project. It's an EU-funded project funded by the Horizon 2020 program and is done by 3 companies. Aura Optic, they deliver the hardware and developed it partly. Optimal Systems, they deliver the general user interface, the data management system, as well as the general software applications to run this robot. And AI UI, we deliver the AI to distinguish the different traces. So what is this project all about? First of all, it was the idea to create a robot that is capable of distinguishing different traces from crime scenes. So imagine you got a criminalist that takes traces from a crime scene via a tape system, and after that it gets sent to the laboratory, and the laboratory workers, co-workers, use these traces to find out by looking under a microscope what they can find. So humans normally distinguish different traces on these trace carriers, these tapes. And this is a really most detailed process. So we wanted, or better, the laboratories wanted to find a way to automate this process. So they asked the EU said yes, and now we are in this project. Right now it is already phase 2. That means we have built a prototype, and we want to show you in this short video what is the state of the prototype right now. You can see here on the left side CAD image of the prototype, and something like a process step by step how the AI got fed with image data, how the image data is processed, and what is the result. So first of all, one of the specifications was that we will have to be capable to process a trace carrier with the size of so-called A4 format. And we scan these A4 format trace carriers with multiple steps. That means we got a camera that makes images of about 150 megapixels. We strive to reach the resolution of 1.5 microns per pixel. So we have to take several images to get the whole surface area processed. Okay, so we process the image data, we prepare it to feed it to the AI, because 150 megapixel per channel is much too much for an AI. So we break it down to a level that the AI can read the image data. After the feeding of the AI, we get a result in form of a text file that just states, okay, on that pixel you will find for example, a fiber. This pixel belongs to sand, and this pixel belongs to blood. Okay? You can find more information on the shuttle pcp.eu homepage. Here we'll see a short video of our prototype, how it's built and how it is looking. We have no nice footage of the prototype from the laboratory, because it is a prototype and there are all hanging around cables and stuff, and so I am here to show you a virtual video of it. What you can see on the back right here is something like a storage for trace carriers, so that the machine is capable of getting fed by different types of trace carriers, and through the day it will work one after another until it's finished. So you can add up to 10 trace carriers, and after that, you can see here, they will get fed to the robot itself. You got here in the middle the optics, as well as on top the camera and the filter revolver, where different kinds of lighting will be set up. Yeah, on the bottom you will find the light source. So that's it in general from the robot itself and about the project, the funding and so on, the working companies. Let's dive deeper into how do we get an AI to distinguish different kinds of traces. We got our software right here, AI UI, to create AI. And in this case, we use image data. Sure, we use image data to classify traces and for instance segmentation. That means we put out an image into the AI and we want the AI to tell us what pixel belongs to what class. And therefore, we need supervised learning. That means a human, a supervisor, in the first place has to tell the AI what is a trace and what's not. So that means, if I show you this right here, we got our toolkit where we label the data. That means you got this image right here and we label it. That means we go ahead and take a tool like Polygon, for example, okay, and say this area, for example, is, it's right now undefined because we just draw it, but we can name it Baumwolle, that means wool in German. And what you can see here is virgin wool, black colored. So we go ahead and we take several images, thousands of images, and annotate them. This can be quite awful, I would say, but in the end you have to show the AI what you wanted to distinguish. Okay, you can see right here that's red wool, red colored wool, and the first three channels right here on this image stand for the white light channels. That means white light filtered by red, green and blue filters as different channels has been created by the toolkit. And if you want so, you can also use the last three channels. These are the channels for first sense. That means these three channels have been measured or have been taken by the camera under ultraviolet illumination. Okay, so you can see here this red colored wool isn't glowing in this light, but you can see here there is some in the background, some dust or whatever, some traces that have not been annotated. But we just annotate the traces we know exactly that are belonging to one class. So in conclusion, we take images, we annotate them, and then we get a data set where we can train an AI to learn, okay, what is a fiber, what is sand, what is glass, what is blood, or what are human skin cells. These are exactly the 5 categories we are working with right now. So let me show you this on the Shuttle Toolkit itself. What I've shown you here in this software is just the software to train the AI and to test it. Okay, but what the operator will see later on is exactly this, the Shuttle Toolkit. Right now we are not on the version 1.0 yet, but we strive to reach it fast. So let me show you how an operator might use this toolkit to find traces. Okay, first of all, like I stated before, you can make acquisitions. You can start an acquisition. That means you got a trace carrier online in the stack and you say, go ahead and scan this trace carrier. Okay, and if you have done this, you will end up with this kind of image, for example. So you got several 150 megapixel squares. Because the image is too big, you have to take several pictures, as I stated before, to have everything recorded. So what's next? Okay, we will have later on something like a summary on this site where you can see roughly what you will find on the whole trace carrier. Okay, right now we are in a state you can click on, for example, just the image, and you see an overview. Okay, you can choose over here if you want to see the reflection or fluorescence, for example. Okay, let's start with the reflection right here. So the images are very big, so it is really nice that we can zoom in and out without any time to waste. And what we have here right now is just the image taken by the robot. But what we want to add on this is the classification, right? So what you can do here is under trace options, show overlay. That means you get now an overlay of traces found by the AI. You can choose right here the certainty, because the AI is like we humans are, not perfectly certain about everything. That means right now we have the setting minimum score 0.7. That means the AI has to be at least 70% sure about that this amount of pixels belongs to a specific class. That means that this over here is glass. Okay, you can see the score there is 76%. So that means if I go up to let's say 80%, the overlay will change. You will have less traces right here. And if you see here 89%, let's go up to 90, and there is no overlay anymore, because you just get to see the traces found with the certainty you want it to show. Okay, let's go a little bit back down and have a look. We got some different traces on this slide. For example, over here you got glass, and what you see here right now is you got this line in between these traces. Why is that? As I told you before, we had to split up the images because 150 megapixel images are much too big for an AI, and we got 3 channels or 6 channels as well. That multiplies the amount of data. So we had to cut down the images in smaller ones to feed it to the AI. What you can see here is the line where an image was cut and sent to the AI, and the other image follows after that. So, but what you can see here, it is right classified. The AI has never seen these images before. So that means we have trained the AI on data we generated in the laboratory, and got these data sent by the consortium that evaluates our progress. And we have scanned right now these traces. And you can also see right here sand. Okay, we can go a little bit down to make it more smooth maybe. You can see sand as trace, as well as fiber. That's all written in German. And yeah, quite nice. What you want to do sometimes, and maybe ask yourself right now, is how can you further process the information you got here. For example, if you click on this trace, it's a fiber, or you can click on it right here in the list. You can click on informations. You get a small plot of it and some information. How big is it, the area, the length, as well as a score. How certain the algorithm is that this is a trace, for example, that this is a fiber. But you can also open a spectrogram. Okay, you get now a spectrogram of exactly these pixels, because we don't work by, let's say, point-wise acquisition of information, by light beams or whatever. We work with the whole field of view. We use cameras and optics to get all the information normally would have gathered by light beams or something in the whole surface. Okay, so we got a lot more information than in a standard machine. Let's have a look at another trace, maybe this one, for example. Yeah, okay. So if we activate the overlay, you will see these one here. These are blood traces. Let's dive deep in. But first of all, I want to show you what is this around the blood trace. So if you glue a trace via a tape on an object carrier, you will end up with air bubbles in between these two objects, because this trace in between is mostly three-dimensional, okay, and this means you will have to include air bubbles as well. So this is what you get, and as stated by the algorithm, it found several blood traces right here. So also here, all the traces got different colors. You can change this if you want. Let's zoom in, and you can see it looks like blood. You can change the dynamic range of the image if you want to, but in this case, if you go more far to the right, you will see it's getting darker and darker, and we want to see it clearly. Okay, so we found different blood splatters as well as down below here. Okay, so the algorithm works quite well. Also, you find some fibers, sand again, and also again you can go ahead and click on the blood trace, for example. You can also double click on it if you want to, and found out about the spectrographic information if you want so. Well, that's roughly what the Shuttle Toolkit is already about to do. It's not perfect yet. We are in a phase of prototyping right now. So far, we achieved a lot of interesting results right now, and we strive to optimize it even further, so that the whole acquisition process and the whole information gathering of what kind of traces to be found, how many of them, how big, and so on, can be seen within a glance. Okay, that the operators that work in laboratories can focus on the real work, and we strive to optimize this via AI and a lot of automation. Thank you for your interest, and if you got questions, just let us know. If you got criticism, also that, and have a nice day. Thank you.